All right, folks, on this episode of the Supplement Lab, we're going to be talking a little bit more about immunity, how to activate these little white blood cells, and a little bit about gut health. On this episode, talking about ARC on the Supplement Lab. So, we've made a product before, Super Shroom. It does have to do with immunity, but it's only merely one facet of immunity. And you've actually got a pretty complex immune system that's made up of a ton of different cells that do a ton of different things. So I thought that we could elaborate on this concept just a little bit more, not only with this product, but with this episode and what I'm going to show you here. So just to start out, I'm going to give you a little background on the immune system itself. You've got the innate immunity, which this consists of like physical barriers like your skin. Your skin produces sweat. There's even different types of antibodies and stuff in your sweat. There's also other excretions from your body that are actually kind of protective and actually keeping pathogens at bay or fleeing them from your system. But there's also the GI tract. All the mucous membranes that you have also will have either immune cells that are there or different secretions that help fight off these different infections. And then there's your blood-brain barrier, which is another mechanism that's inside your body that prevents different pathogens from getting into the most vital parts that we have. There's also inflammatory responses. For example, if you get bit by a mosquito and it itches and you scratch it, all these things are part of a pro-inflammatory cytokine response. Swelling on its own is also another version of an immune response. There's the complement system that we actually did talk about in Super Shrooms and how this is something that can increase phagocytic activity of your white blood cells. And the actual activation of the immune system itself, or of the adaptive immune system, and that's from antigen-presenting cells. This goes to other white blood cells, which tells them that there's a foreign invader, and then they end up killing it. So this process of activation is something that's needed. But there's also different things. There are what are called the MHC class of different proteins that are going to be expressed on the cell surface of different cells. And basically what this thing does is it will present different peptide fragments and stuff to different immune cells. These will be outside on the surface of a cell. The immune cell will see this and say, oh, well, we got to eat this. But what's interesting is that if it's part of a dead cell, then it's something that'll turn off these white blood cells where it's either, they'll just be recognized by a different cell type and then those will eat the dead cells like macrophages. But otherwise, if it has something special on it that's from a foreign pathogen, it will tell these guys to go and send off more signals to come kill this pathogen. But also, after that, we have the adaptive immune system. And this has more to do with the recognition of self from non-self parts that are found inside of your system. If there's a foreign bacteria, your body will recognize that as non-self. But if it's like a dead cell, it'll recognize it as self, and it will go through its own pathways of destruction that way. There's also certain responses that have to be generated to eliminate, different pathogens or infected cells. Sometimes if it's bigger than a particular microbe, say it's a worm or something, there's a whole process involved with that. And then there's the development of immunological memory. So every pathogen that you've come into contact with throughout your entire life, there's a record that's kept. There's a record that's kept on a cellular level inside of your body. So in case your body ever comes into contact with that foreign pathogen again, your body says, hey, we've seen this before, we're used to this, we've already slain this beast one time, so we'll just do it again pretty easily. Now to talk about these actual cells that we're going to address here, I've got this nice little chart. This is a chart of your white blood cells. There's one that I'm excluding from this, but I'll talk about it in a second. So first of all, we have the neutrophils. The neutrophils account for 60 to 70% of your white blood cells total. They target bacterial and fungal infections. So these are other microbes and stuff that you come into contact with. Like I said on a podcast the other day, maybe you went and picked up some dog poop in your yard and then happened to stick your fingers in your mouth. It's a complete accident. You don't know what's happening, but that's one possible way of introducing a foreign bacteria to your body. Fungal infections would be things like Candida albicans. These can develop inside the gut, and you can have Candida, and that can compromise your nutrient absorption as they create this biofilm through your whole GI tract. Or typical yeast infections, also caused by Candida in the lady parts. So that's another thing. These are the most common first responders to all types of infection. They've got its own specific morphology where it's kind of globular. It's not quite as spheroid as the rest of them, but that's neutrophils for you. Next is the eosinophils. These account for 2 to 4% of your whole white blood cell, number in your body. These target parasitic infections, and this is like what I was talking about earlier. They target things like worms and flukes and things that are a little bit larger. And since those types of infections are pretty rare, that's why their number is so low. But if you ever do have a situation where you are infected by something like this, the eosinophils are involved there. But they're also involved in allergic responses. And these guys are part of a more complex type of reaction that also involves the basophils, but I'll get to that in just a second. These are bilobed nuclei that are found inside of these cells, but they are also spheroid, and all the rest of them will also be spheroid. Basophils, they account for 0.5% of your total white blood cell number. These are involved more in allergic and antigen responses, so if they do see a foreign antigen, it's a matter of producing swelling and inflammation and other cytokines. These are also involved in the release of histamine. So if you do have an allergic reaction and your body's trying to get rid of it, the histamine gets released and you end up having an allergic reaction. Lymphocytes, these guys are actually pretty cool. It's composed of B cells, CD4 plus helper cells. You've got the CD8 cytotoxic T cells, and these operate primarily in the lymphatic system. They don't really hang out in the blood as much as they do the lymph, and it has to do with a lot of other types of phagocytic clearance. The lymphocytes and the monocytes are your primary phagocytic types of white blood cells. These are the guys that go and they hunt down different types of bacteria and other microbes in your body. But the last one on here is the monocytes. These are the major phagocytic types of white blood cells. They are the ones that recognize foreign pathogens the most. They present antigens to T cells. They're precursors to the actual macrophages, which are not featured on here, but they are the biggest, largest of all white blood cells. They have an amoeboid structure. They are the ones that are really out hunting, seeking, and destroying foreign pathogens. In addition to that, they also eat your dead cells too. So they're handy. They go around. They clean things up. They can be found in the lymph, and they can be found in any tissue type because they do have that amoeboid structure, and they can slither into any crevice that your body needs it to get into. So, talking about this formula, now that you've had a little bit of background, ARC is really interesting. It's only got a few ingredients in it. I want to say there's 7, and the first 2 that are worthy of note are copper and zinc. And we all know that zinc is something that most people will take to enhance their immune system, but it's really because if you have deficiencies in zinc or copper, then there's several different things that can happen on an immunological scale that are not quite good. You have a decrease in IL-2 production, and IL-2 is particularly important because it has to do with NK and T cell proliferation and activation. So if you don't have high IL-2, then your NK and T cell activation and proliferation is a bit compromised. Overall, there's also a decrease in cytokine production and antibody production, which is part of the adaptive immune response. In addition, you have a decrease in phagocytic activity, so those white blood cells that are responsible for taking out these microbes are not doing their best job. And then there's also the interferon gamma pathway that also gets downregulated, but this actually is something that is involved in the combating of different viral pathogens, and it's also something that also upregulates the MHC antigen expression. So if you have a compromised interferon gamma production, all these other things that are involved with an interferon immune response are also decreased. It also decreases the amount of thymulin that your body can produce, which is actually a zinc-dependent thymic hormone. It's involved in T cell differentiation and an enhancer of NK cell and T cell activity. So you definitely want to have your zinc and your copper in order. We've got 10 milligrams of copper in here with, or 10 milligrams of zinc in here with 1 milligram of copper. And zinc and copper actually have an interesting balancing dynamic relationship. If you have too much zinc and you don't have enough copper, this can actually worsen a copper deficiency. So whenever you do intake zinc, you want to consider taking copper along with it. A lot of these products are kind of separate, or, you know, in a best case scenario, you can find a zinc copper combination where you don't really have to worry so much about creating a copper deficiency. Next is the bioflavonoids that we have in here. Now, typically when I do these videos, I'm going to go through them in the order of least interesting to most interesting. The bioflavonoids we actually talked about a little bit in Serenity, and they're peppered throughout quite a few of our products. And like all bioflavonoids, these are stuff that quench reactive oxygen. They eliminate free radicals. And because of that virtue, because you don't have a high level of reactive oxygen species present, they can have an anti-inflammatory effect. But most bioflavonoids actually have a directly anti-inflammatory effect through the downregulation of NF-κB, which is a pro-inflammatory cytokine. In addition, these inhibit microbial adhesins by actually sticking to the microbial cell surface or their cell envelope proteins. But when it comes to the bioflavonoids, and in this case the citrus bioflavonoids, there's over 6,000 structurally identified flavonoids that exist. Your typical suspects in this bioflavonoid class are things like quercetin, apigenin, hesperidin, luteolin, the things that you've seen in quite a few products already, but you just don't really, know their identity. Next, quercetin is probably the most studied of this entire class. We do have that in Serenity, but it's also in here in trace amounts inside of the citrus bioflavonoid complex. And quercetin is associated with an upregulation of type 1 interferon secretion, which is nice. It also inhibits replication by directly binding to host cell receptors where the virus or bacteria could possibly stick to your cells. They're also, somewhat involved in the inhibition of actual replication machinery, and that will have an effect on the actual viral genome transcription or protein synthesis or all the different parts involved in the replicative process. Next up is phycocyanin. Now, phycocyanin is something that's also been featured in sedative and a little bit in flight, but this is something that comes from spirulina algae. And if you know anything about spirulina algae, that it's a blue-green algae. And part of what we know about spirulina is when you see it, it's a very green texture, but at the same time it is considered a blue-green algae, and that comes from two different pigments that are found in it. The green one is chlorophyll, which we've already talked about in Super Green's video, and the different types of effect that it has. It actually will activate the phase 1 antioxidant enzymes like SOD, catalase, and glutathione S-transferase, but the blue part is from phycocyanin. And that's why sedative is blue, because it's that blue pigment. And this also contains a very similar structure, the tetrahydropyryl ring that we talked about in the Super Greens video. Now, this is something that's shared from chlorophyll also with phycocyanin, but the most potent antioxidant activity from phycocyanin is that when that ring will actually break open and it forms something called phycocyanobilin, which is something that has a more potent antioxidant power, and it has an impact on the ERK12, JNK, P38, and the IK beta pathways. And this is where phycocyanin gets its antioxidant, anti-inflammatory, and immunomodulatory activity. So the cytokines that are regulated from phycocyanin, there's an increase in IL-1 beta, an increase in IL-2. We just talked about that earlier and how it activates NK and T cells. There's mixed evidence on what it does to IL-4. Some studies say that it goes up and some studies say that it goes down, but we'll touch on this again in a bit. It decreases IL-6, which is a pro-inflammatory cytokine that's mostly associated with fever. It also has some activity on IL-10, TNF-alpha, and interferon gamma. Another thing that phycocyanin can do, or at least spirulina can do, is activate what are called the toll-like receptors, which these things are actually involved in recognizing foreign pathogens and part of the whole immunosurveillance program. It activates something called IL-12. This activates natural killer cells, and then this will subsequently activate interferon gamma, which, once again, that's involved in immune surveillance, finding different pathogens and eliminating them. Spirulina and phycocyanin also can increase macrophage phagocytosis, which is the big white blood cell that we wasn't really talking about here. It actually looks like this little guy. And in case you're wondering what these little guys are all about, I actually bought this kit. It's if you go to a website called giantmicrobes.com, you can find little guys like this white blood cell, or maybe you can find this antibody, or maybe you can find this little Spanish flu on their website. I actually, this week in Goon Games, will be giving away the box of the blood cell kit in addition to the Plagues kit. So whoever wins Goon Games, you get these things too. Moving on from phycocyanin, we've got lactoferrin. Now lactoferrin, these last few ingredients are probably my favorite. Lactoferrin is it's a type of immunomodulator that's found from milk. It's called ferrin because it's an iron-binding protein, and it's usually found in milk and colostrum, actually. So there are trace amounts of this that are found in flight, but we actually have standardized lactoferrin in here. So it's 95% pure. It's really nice. You get 150 milligrams, which is a pretty substantial dose, and it's a really expensive ingredient in general. Now, the synthesis usually occurs for lactoferrin inside the different mucosal lining that actually is part of your intestinal epithelium, and there's different types of activity that lactoferrin has. It can actually bind to host receptors, kind of similarly like I was talking about with flavonoids, And by blocking host receptors, it can block any kind of viral entry. It actually can bind directly to viral glycosaminoglycans, which are part of their structural envelopes, and it can enhance the expression of antiviral cytokines like interferon alpha and beta, and that also will enhance natural killer cell activity. In addition, lactoferrin decreases reactive oxygen and therefore inflammation, and it does this by sequestering iron that usually would be found throughout the body, but there is such a thing as iron catalyzed, free radicals that can actually make more damage because there's actual iron present. So by sequestering this iron, it actually takes advantage of that activity and will then use it on foreign pathogens. And it can actually destabilize the lipopolysaccharide cell membranes of actual bacteria. So that's kind of a cool thing. Now, lactoferrin is really interesting because it will bridge these different types of immune systems. It will bridge the innate immune system to the adaptive immune system. With the innate immune system, there are actually lactoferrin receptors that are found on the cell membranes of macrophages. So there's a signaling role there. But it also will work on the adaptive immune system by modulating interferon expression and NK cell activity, like what I just said previously. So it also works on the maturation of B and T cells. So there's several different ways that lactoferrin can enhance immune responses to foreign pathogens. So in addition, there's activity from lactoferrin against bacteria, fungi, viruses, and it actually has been studied in a clinical setting for cold influenza, gastroenteritis, summer cold, and herpes. But, take that for what you will. Next on this list is the Gerakan mushroom. I just spit out of my mouth right there. I'm going to take a drink of water. We'll start on the Gerakan. Next is the Gerakan mushroom. Now, this was a passion project for me on finding this Agarikon mushroom because this is a particularly rare mushroom. It's just really hard to find. There's not many supplements that are currently on the market that even contain Agarikon mushroom. Now, like all mushrooms, which I do love very deeply, they do contain beta-glucans, and that can increase phagocytic activity by activating the complement system. But just the story of Agarikon on its own, it's actually been found with the Iceman. And if you've ever watched like the Discovery Channel and found like they found this Iceman in like the Himalayas, and he had like a pick and some other stuff, he was wearing animal pelts, there were samples of Agarikon with him that were 5,000 years old. So this has been known about for quite a long time, and it's had actually wide use spread throughout the entire northern hemisphere through a lot of the Asian countries, a lot of Western European countries, and also within the United States because of this tropical climate, or not tropical, but more of a deciduous climate zone that it grows in, because they typically grow on conifers or things that are of a northern latitude, those specific type of trees, and they're part of its death phase. They actually cause rot in these trees, and then they grow. And the thing about it is their fruiting bodies are really big. Like, they're big and they're cylindrical, and they're not like your typical kind of mushroom that you would ever kind of find. But some fun facts about this thing: because it's so old, it was actually once believed to have supernatural powers. It would facilitate contact with spirits, and it was placed on the graves of shamans to protect them from evil forces. They were known as grave sentinels, and that's just some cool mythology behind it. But it does have things inside it that actually do things for your immune system, like triterpenoids, and the specific triterpenoids found in Agarikon are called fomitopsins. There are also organic acids, coumarins, different polyphenols that are in there, and if it's got polyphenols, of course, antioxidant, anti-inflammatory, so on and so forth. But it also has those polysaccharides, the beta-glucans that are found in all mushrooms that help increase phagocytic activity. As far as the actions that it has, it's considered to be a broad-spectrum antimicrobial. It will actually help your body fight off a whole slew of different pathogens that can invade your body that I'm not going to get specific into. Like I said previously, it's also antioxidant, anti-inflammatory. There's some anti-trypanosomal properties. It's probably broadest history is to be used for consumption or having an anti-tuberculosis effect. But in addition to this, it can also decrease virus-induced cell damage by 50%, and that was based off of a study that was done by Paul Stamets. If you know anything about Paul Stamets, I actually mentioned him in the Super Shroom video. So if you haven't gone over to TED Talks, looked up Paul Stamets, he's got to talk about how 6 different ways that mushrooms can save the world, and he's got a really nice soapbox about Agarikon mushroom, and I highly encourage you to go watch that video. Last on this whole list are things called phages, bacteriophages. Now, this is a kind of virus that doesn't kill you. And instead of killing you, because you're just not on the menu, it kills bacteria. It selectively chooses to go kill bacteria. And these bacteriophages are actually the most abundant type of living species on the planet. Now, in the Super Shroom video, I said the largest species on the planet is actually a mushroom, but I'm saying that this is abundant. So the number of copies of bacteriophages are what make them so abundant, even though they're not the largest amount of biomass. And if you go to the ocean and you take in a mouthful of seawater, you're actually consuming a pretty substantial amount of phages that way. People who live in more coastal environments would theoretically have a more biodiverse human gut phagome than someone who lives in the middle of the country where they don't have access to ocean water. But this human gut phagome does exist. And it's been shown that if you have a not very biodiverse human gut phagome, that GI disturbances will actually go up. So there's this inverse kind of relationship. If you have more phages, you have less disturbances, but if you have less phages, then those disturbances can pop up. But overall, these things have a beneficial role to the human gut ecosystem by introducing this predator-prey kind of dynamic. And what they do is they kill bad bacteria. And I'm going to go over to this chart right over here. So a bacteriophage, it is kind of a scary looking shape. I mean, up here you've got the head of this actual virus, which looks like a lot of the normal viruses that you would see in your traditional textbooks. However, it has this tail portion and it's got these tail fibers, which I like to call legs. So this thing that looks like some sort of creepy crawly part spider, part virus thing that's attached by a stick will come and attach to the outside of the bacterial cell. This is phase one. It's called detachment. There are receptors on the outside of these bacterial cells that these viruses can actually take advantage of, grab onto, and we go to phase two, which is the entry of the phage DNA and the degradation of host DNA. So once it's latched on, it pulls itself closer to this little tail portion here will shrink down a little bit, and the DNA that's usually kept inside the head will come into the bacteria, start splicing itself into the bacterial host genome, and integrate itself that way. And this is a similar mechanism how viruses infect humans. However, once again, this is specific to specific strains of bacteria. Next is the synthesis of the viral genomes and proteins. And I've got this kind of shown here where I've got random heads and random legs and random tails that are being developed along with the DNA strands. And then after this process goes through assembly. This is where the finished product of the bacteriophages happens. And what will happen is this bacteria will begin to swell and swell with all these copies of the new phage that's actually in there. And then we have our final phase, the number 5, the lytic release of the new phages and the death of the host. So it basically impregnates these cells, blows them up real big with a ton of copies, the cell explodes, and then those bacteriophages will then spread again to other cells that are in there. Now, the cool thing about bacteriophages is that they're self-replicating. You know, it's self-replicating, like it's in a way like if you were to, say, take some sort of medication that could create more medication inside your body, that would be kind of interesting. It's like a one-and-done pill kind of scenario. But, you know, the thing about this is bacteriophages are so focused on a very, very small species subset that as soon as that particular species is eradicated, then these phages will go away. You'll simply poop them out and you won't have them anymore. So they're self-regulating, self-replicating. They target a very narrow range of bacteria. There's no human microbiome disruption that you would find like if you were taking like an antibiotic to do a similar kind of a job. They actually provide a prebiotic effect. So these dead pieces of these cells that were once alive that got infected by the phage will actually act as food for the other bacteria that also populate your intestines. And there's not really any side effects from these things because these viruses could care less about a human cell. They're out there hunting things like E. coli. Now, there's a lot of things that can cause different types of imbalances in the human gut. You can have like a dietary change, you might just have not a very good lifestyle, you can have a high stress, or you can actually take an antibiotic regimen had you caught some sort of other pathogen. Now, the problem with this is that a lot of these antibiotics, they're very broad spectrum. And when it comes to taking antibiotics to get rid of one specific type of a bacterial infection, it tends to take them all out, which, you know, it's quite effective, but at the same time, it may not be particularly necessary if you're only trying to target one type of bacteria. Now, originally, when these things were discovered, the first isolation of a bacteriophage was back in 1917. And up until about the end of World War II, these things were extensively studied for potential use as antibiotics, which is kind of cool. And they were doing this in different phage cocktails, so they were mixing different types of bacteriophages together, seeing what they would target, and then they were using that for specific antibiotic regimens before penicillin and broad-spectrum antibiotics came about after World War II. So that's where they came from. However, the stress, all the different lifestyle changes, dietary changes, what this can do is it can cause a bit of an imbalance in your actual human gut microbiome. And what that does is it can actually make you susceptible to opportunistic infection by commensal bacteria with things like E. coli, and you can get sick that way. So PreforPro is the actual blend of bacteriophages that we have in here. This consists of 4 different types of bacteriophages. 3 of them are part of the Myoviridae class, and that is the actual T4 bacteriophage. This is this type of phage that we're looking at right here. So 75% of what you get in this is this morphology of bacteriophage. The other one is the Cyphoroviridae. It really just doesn't have the legs, but it does the same kind of job as the rest of them. So what they are, it's a blend that is specifically targeted for E. coli. There was a study that was done with this ingredient looking at safety, tolerability, and its actual effects. There were 32 participants in the study. It was a 28-day long study, and they only took 15 milligrams of PreforPro that's found here in ARC, and they were looking at what kind of changes happened. Now, there was definitely variation in changes across the entire study group. There were some people in the group that didn't respond very much, and then there were some people that responded extremely well. But what they did find is that there was a significant reduction in E. coli bacteria. But in the hyper-responding group, there was no E. coli detectable at all. It was completely eliminated. This was also followed with a 4 to 5 times increase in the eubacterium species that normally populate the gut. And these are actually good bacteria that produce butyric acid and helps, slide your digestive juices around as you get ready to poop. This is actually a beneficial effect, and by knocking these E. coli numbers down, it actually allowed the population of this other good bacteria to flourish. In addition, this also decreased IL-4 levels, and that's another pro-inflammatory cytokine, and if you can decrease that through this kind of a phage therapy, it's kind of a good thing. There was also a 5.5 times increase in Bifidobacterium bifidum, which is another really good probiotic. You definitely want to have good amounts of Bifidobacterium bifidum in your system. Those also produce butyric acid, which helps you poop. And then there was also a 75% decrease in Clostridium perfringens, which is actually a bad bacteria, which I found this to be probably the most interesting finding within this study because, Clostridium perfringens it's a very minor component of the human microbiome, but in addition to that, it's also a typical kind of a foodborne pathogen. But what was interesting is these bacteriophages were actually targeting E. coli and ended up taking out this other bacteria by 75%, which is also really cool. So this is a pretty cool product in general. This is something, if I did this in the write-up, if you're like going to a foreign country and you don't want to get sick, or if you're in a large gathering of people where sanitation's not all that great, you might want to take it in that kind of a setting, or if you feel like you might be getting sick, it might be a good idea to enhance your immune system. Anytime you want to enhance your immune system, ARC's going to be one of your go-tos. It's a little heavy-handed, but it's something that we wanted to do to create an immune product that was different from all the other elderberry, echinacea, vitamin C, and all that other stuff's out there. So this is ARC. It's a heavy-handed, broad-spectrum immunostimulant, and, if you happen to need it, go on and take it, but at the same time, it's also going to do good things for your gut. This has been ARC on the Supplement Lab.